Okay, so continuing on with our project, this is Nate Nessler for Hyperactive Studios, and we're getting ready to do video number 3 here, and in the series, and episode 3 if you want. And basically, we're going to go over if statements and loops, and also random numbers. So we're going to get into how to make a computer act like it's rolling a dice, or think of like random numbers from the lottery or whatever. Of course, you'd never want to do that. I'll get into why in a bit here, but let's have a little fun with this real quick. Okay. All right, so I'm going to create a new file here, like this. And let's see here. Let's move this over and spread this one out a bit more. Okay, so one of the first things I want to put in here, actually, since I'm going to just go over random numbers right away, is first I need to do something here. And instead of an event here, yeah, let's say let's do it like, let's see here. Alright, so what we need to do is import. So these programming languages like Python and such, they have libraries so that you don't have to do everything yourself. You don't have to remember everything. Actually, a good bit of the programming has already been done. It's out there for a long time now. And you can just import those libraries. So if you need to do XYZ tasks, the best idea is to check to see if there's a library for it first before you start developing a whole bunch of stuff that's already out there and been already tested, hardcore, worked through. 19 people have battle tested that thing, and it just runs great. So there's no point in reinventing the wheel basically. I'm gonna say time. I don't like that. Say times. Number of times you say something. All right. So let's do it. We're going to say between 1 and 10 here for right now. And this is going to tie into our previous little discussion a second ago. All right, so if I have say times here, like this, and then I say, let's see, our child message, child talk. Let's call it child talk this time. I don't know. I don't remember what I called it last time, but anyways, child talk, and say, are we there yet? And so there's the question and question. All right, and we have it randomly generate. So, and let's turn this into a function. So let's say def here, and let's say child car ride. I don't know. Just make it a little more realistic here. Oh boy, child car ride function. So, what happens when we run the child car function? Well, a couple things could happen. Let's just figure it out real quick here, actually. And we could determine this. Let's call it message, and make that equal to say times here multiplied by child talk. All right, just like that. And then that's going to create a repeating message. And then we can just return that. Awesome. All right, so nothing new here except for the random integer. And what this is going to do is let us select between 1 and 10. 1 and 10 times. This child could say, are we there yet? And it's random. It's going to be an integer in this random range here. And that's how we set our range, basically, between our numbers. Okay, cool. So let's look at actually running this now and displaying it. So if we do another def here real quick and call it main, just like we did before, close parentheses, enter. All right, cool. And let's run our function child car ride. So that way we're simulating a child car ride here. Awesome. All right. And the problem with this, of course, is that we need to print our child car ride. So this is cool. Like before, we didn't have anything like this. You're probably going, huh. Well, the cool part about this, let me just go ahead and add a space in here because I want one. Otherwise, it's going to look stupid. They'll all be just smashed together. We don't want it to be smashed together. Okay, let's see. Child car ride. And this will get more and more interesting as we go through this little example here. So, there's our child car ride. And so basically, when the message variable gets returned here, it's going to be displayed with the print statement. Now remember, the message variable is going to be nothing but a string. So it's going to be nothing but text. And so we're going to be returning all that text. And then here, we're going to be displaying that text with this print statement. Right? So cool. I'll prove it. Main, open close parentheses, like so, enter, and save. Update that, and we should run this and get something. Are we there yet? Are we there yet? Are we there yet? Yes. Awesomeness. We are there. All right. And how many times did it do it? Well, it did 1, 2, 3, 4, 5. 5 times. Okay. So, of course, that was between, you know, 10 and 1. Let's run it again. Why run it again? Don't we get the same thing? Nope, we sure don't. Check it out. We got it. They said it 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So, when we're simulating a child, we can't assume that the child is going to say it the same number of times each time. Instead, we need to make it to where it's random as to how many times the child says it before, you go crazy. So, let's go ahead and save that. And let's do a bit more with this. Okay. So we can start introducing some other ideas here. And what we can introduce in this is how we can pass in variables to a function and how we can do a condition test statement, or an if statement, if you will. So let's have a look at that real quick. Def. And let's call this parent response. Right? It's a function now. And child say times. Let's just call it say times. I like say times. Well, I'm gonna get this across to you that this is a different variable. Hey, I just named it that because that's what I wanted to name it. Colon. It's kind of descriptive. All right, so I'm in here, and then what I can do is I can now do statement. Wouldn't it be nice if we can have it where we have different responses to the child based on something they say? And that would be great. So let's have a look at that. All right, so if the child has said child say times is less than, let's say, 3, all right, I'm going to do a colon again. And then we're going to say, notice we're tabbed over twice, because not only is this code sitting with inside the function, but this code is now also with inside this condition. So we're saying based on if the child says, I can say less than or equal to. So if the child says less than or equal to 3 times, are we there yet? Then what do we say? Well, we're going to say no. Parent's just going to say no, and that's going to be the response. So parent say equals no. No. Maybe we're not quite annoyed yet, so maybe it's not exclamation part. No, it's just no for now. For now, anyways. All right, and so now we've set what our parent say is going to be. And now I'm going to say else. Can I say elif? Yeah, it's elif in this language. Okay. Sorry, I know lots of languages, like close to probably 35 programming languages, something like that. I don't know. Child say times. And let's say, well, what if they less than or equal to 6? Parent say equals don't make me turn this car around. There we go. But what if that's not enough? Elif child say times is greater than or equal to 9. colon parent say equals, I will pull this car over. And finally, if all else fails, if they actually say it 10 times else, right, because the 0 to is 1 to 10, right, then we have a different response. Equal, and then something like, I am going crazy. Commit me now. Just for fun. So I'll probably want to put a space at the end of each one of these little sentences here, so that way, it doesn't get jumbled with anything. All right, awesome. And then after all this, we need to do one more thing here. We need to return our parent say. Awesome. So now in here, what I can do is I can say add, and then we'll say add parent say. And I could put this in parentheses here, and I should, but it's going to work the way it is. But if it makes you feel better, putting parentheses around this is not a bad idea. Matter of fact, I encourage it, but you don't need to. Okay. And parent say, I'm sorry, not parent say. This is be parent response. So here we defined our function, but up above we're going to use it. And there is something important about this. Since we're going to be using the function that's below it, we can't do that. And I'll explain why in just 1 second. Let's see here, say times. Yeah. Say times, we're passing it in. Okay, cool. And so that's going to get added on. All right, so now this function, we need to cut it out and put it up above. So I need to come down here, select it all by holding down Shift and using my arrow keys to cut it. To select it all. And I'm going to hit Control X as in like X-Men, I guess. Hit X here to cut that. And now say Control V to paste it. There we go. And it's going to paste it up above. Why do we have to do it above? Well, because this is actually considered interpreter-based language, which means it actually executes each line of code one by one. And the problem we're going to have here is that if I have this function right here below this function here, literally when this function calls this parent response function, it doesn't exist. See, yet. At that point, it exists after this function, but in that case we already got an error because it doesn't know what to do. So we have to tell it that this function has to be above it so that it knows that this function exists, before it ever gets to this function. So this function must exist prior to this function, since we call this function here where it's getting defined. So since we're calling that function, it must exist prior to the function that's calling it. Has to in Python. It's required. Must. Otherwise, there's no way for the computer to read it, because the computer reads it in order from top to bottom. And so basically it's how it works. And so, if you don't have things in a certain order on this where, you're calling something before it exists, then that's a problem. The computer's going to have an error. It's going to freak out. It's going to be like, no. So can't do that, and that will be an issue. So that's why we have to put it up above. All right. Yes, we must save. And there we are. Okay. And we have, are we there yet? 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 Don't make me turn this car around. So our simulation is working great so far. All right, let's have a little more fun with this. We can run it again and see what we get with this. That one. All right. So let's do this here again. Let's run it again. And we may get the same response. We may get something different. Okay, we did get this one the same. But you noticed we said, are we there yet? Less times, but we still got the same response. All right. Run it again. Oh, wow. So they managed to say, are we there yet? 10 times in a row. 10 times in a row, and then we say, I am going crazy, commit me now. Awesome. So now so you can see we can make different decisions on what to do based on certain conditions that occur. And this all transpired because we have this if structure here, this if statements here, where we're saying, hey, if this happens, then do this. So how does this work? How does this work? Well, basically, right here we say parent response say times. So the number of times that the child is going to say it. So we got that from over here, right? Say times when we did a random integer. And we're passing that number here that's stored inside that variable into this function, into this variable over here. So we're passing the value from this variable here to this variable here when we're calling this function. So then now this variable holds the same value that this one here holds. And so then, it's self-contained. It's contained within just function, and everything that this function is going to do is within this function. So it makes it easy because then we can just break this down to small pieces of code like this, and then we can test each piece. And so we didn't start out with this whole program that we have now. Instead, we started out with just car ride and main. That's it. That's all we started with. But see how we added on another function here for another piece of functionality, and then we're able to test it and see how it works. And it's working great. So that means this one's good. We could keep adding more onto this, and we don't have to worry about any of this code that we've already written not working. And we can reuse this as much as we like. We could use this function in many different places if we want, and it'd be great. It just worked fine. Okay, so here we go. We have parent response, child say times here. Child say times here is less than equal to 3. So if it got the random number of 3 or less, we would have said no. We hadn't been lucky enough to get that yet, though. So we never have said no yet. And so we store the value no into our parent say. And then that goes, actually parent say needs to have a space here for the no. Sorry, that was a mistake. Alright, and let's do that one there. Alright, awesome. Okay, and then we have else if child say times is less than or equal to 6, then then we have don't make me turn this car around. So you might be going, well, won't it do both, this one and this one? And the answer is no. The reason why it won't do both of these is because this one failed its condition. So once this comes back as false right here, for instance, one of these where we got 6 of them. Sorry, I should mention that. So say number of times here, 1 to 10, and we get 6. So 6 gets passed into this so 6 is stored into this variable here, and it gets passed to this variable here, and so we have 6 inside of child say times. So then we say, is 6 less than or equal to 3? And of course the answer is no, 6 is not less than or equal to 3. I tell you what, let's do the comment thing again. Alright, so we're going to simulate the execution of this code by comments yet again. Alright, I tell you what, let's do it at the top of the program. It's just easier. Okay. So comments here, let's say times. And let's say we randomly generate 6, okay? And then when we pass say times to our parent response function, then child say times will then be equal to 6 also. And then when we do our condition test here, we're asking £, is 6 less than equal to 3? And the answer to this is false, equals false, equivalent to false, if you will. I'll put this in parentheses, just so you can kind of see it. So that's going to equal false, basically. And then the one next below it, right? What happens on this one? Well, we do have something that's true. And I'm going to point this out. Is 6 less than or equal to 6? And the answer is, yeah, it's true. It is. True. It is equal to 6. less than or equal to 6. So that's why we got the "don't make me turn this car around" message, right? You might be going, well, isn't 6 less than or equal to 9? Yes, but here's the deal. Because we did else if, elif, once it gets one of these true here, so once this one is true, it jumps out of this whole entire block of code. So it gets out of this entire if-else structure. So basically all this code, it exits out of this code right here and jumps to the next statement, which will be this one right here. And so then it's just going to return our parent say. And of course at this point in time, the parent say will be this right here. So this is more efficient, and it's kind of important, especially when you're doing structures like this, where you're saying, well, it's less than or equal to this, less than or equal to this, less than or equal to this. You want to use else if for sure. There's other situations where you want to use a series of if statements that aren't if else, where I'm just saying if like this several times in a row. A good example of that is, say, when multiple conditions could be true, and you want them to be able to test as true. So a good way of putting this is something like a game controller, for instance. I want to be able to go left and up and down at the same time, right? So in order to do that, I need to have two if statements. Otherwise, I could test to see that they're going if and then ignore the fact that they're also having their joystick point down too and not just completely to the left. So because of that, my character, if I just did a series of if-else ifs, then I would just get the character either running to the side or to the front, but not to the side or not diagonally, right? I wouldn't be able to make the character run diagonally. But if I did a series of if statements, I could make the character run diagonally, because I could test to see that yes, we're running to the side, and yes, we're running up. So then we'd be running left diagonal, for instance. So that works out that way if we do it that setup. And then the else is kind of like the catch-all. So if all else fails, do this. That's why it's called else. So, but if once we're done with this whole thing, then we have our parent say here. Now, something I need to do, and oh no, I don't, because I have this else statement. I don't have to worry about it. Yeah, else is the catch-all, so we're good to go. So return our parent, what the parent is saying, and then it just gets added on to the conversation at the end for the parent's response to this. And then we return our message, and then the whole thing gets printed right here. So that gets returned there, and that gets printed. And essentially, that is what's going on. And that's how that program works. And let's see it again in action one more time. Again, we got it 10 times in a row. Wow. It's like really rare to have that one occur. Don't make me turn this car around. Okay, so we got don't make me turn this car around again. And here we got our no. Are we there yet? Are we there yet? Are we there that? Are we there yet? No. So we got that one. So it's working great. Alrighty. You know what? I think we're going to put the loops and arrays in another video. This video is going to work just on if statements for now. So something else we can do too. I want to point this out. We have several different symbols that we can have with our if statements. And here we've been using less than, equal to, or just less than. We actually got several that we can do with ifs. So if testing conditions. Alright, so basically we can have less than, we can have greater than, we can have less than equal to, we can have greater than equal to, we can have pound sign, not equal, and I believe in Python it's just a single one. In some programming languages it's two of them, but I think in Python, if I remember right, it's a single equal sign. I'll test that in just a second, just to make sure. Let's just do a test on that real quick, shall we? num equals 5. I don't know. I'm just doing some test. We'll just have to say success afterwards. All right. Okay. Didn't like it. Awesome. So it is double equals. Sorry, some languages are single equals. It messes with me. Most of them are double equals though. This one's double equals. Okay. So yeah, double equals on this language. And there we are, as far as all that goes. Now, one other thing we want to do besides that, we have relational operators. This is called. So if gosh. All right. So how does relational operators work? Well, we've got a couple of them here. We have if, and or. Like this, and an or. Why does that matter? Well, it's real simple, really. I mean, you could do a whole chart, but it's real simple, the idea. So if one condition is true, or the other condition is true, then the whole thing is true, right? We could also have it false or true, but guess one of them is true because it's a logical thing. Because we're saying if one or the other is true, both could be true and it comes out true, or one could be true. And we could do another situation where we say the first one is true, or and then the second one was not true, and the overall result is true. So basically, if either one of those is true, then the whole thing is true. If both of them are false, then the whole thing has to be false. And you can just kind of like say it basically out loud, and it makes sense. So if this is true or this is true, then the whole thing is true. Otherwise, it's false, basically. So that's our ors, and then we also have our ands. So the and is also very straightforward. It's real simple on it too. It's if this is true and this is true, then do this. Then the whole thing is true. Of course, if just one of them is false, the whole thing's false for and. So it's going to be false on this one. Because it has to be this is true and this is true for the whole thing to be true. Otherwise, anything other than that is false. So if you just think about it in those terms right there, it's a lot easier. I mean, there are these truth tables like this is called, and you could sit there and memorize them. But in my opinion, you should just basically think it through, and when you do, then the whole thing just makes a whole lot of sense, and then you don't have to memorize a whole bunch of stuff. I'm not good at memorizing things, so I'm good at understanding things. So it makes I just automatically gravitate towards an understanding of things because I think it's simpler to do it that way. But this works. But if you want to think of it in simpler terms, in my opinion, it would be if both are true, then the whole thing is true. Otherwise, it's false. Could do this one here too. If one or both are true, then the whole thing is true. Otherwise, it's false. That's it. So if you want to look at it that way, that's how that works. You might be going, well, alright, okay, but what on earth is all this? Well, basically, we can start doing stuff like And I don't know. Let me get this across this way. Alright, so this is going to come out true, and we're going to get success now. Just trying to show you how this works real quick. See how we get success? Now, if I just make just one of those false, you know, like maybe 7, because num2 obviously is not 7 since it's set to 10 right here. So this is set to 10, so this is going to be false. Because this is true, and then this one's false, so therefore the whole thing is false, because with AND, both of them have to be true in order for it to be true. Otherwise, it's false. And I totally didn't mean to do that. Hold on 1 second. There we go. Yeah, and so we didn't get success at all right here. We got nothing. If you want, we can make that a little more apparent here, where, you know, if it's not true, else it's false, basically. And then we're going to print failed. Because if it's not true, then it has to be false. Which means it's going to be failed. Success failed, that works. So black and white. And we failed. Yay. In my opinion, this is a success on the upper part, though. Just one time, and the no silenced it. Wow. Alright, so what if we had a different scenario, right? What if this is an AND? What if this is an OR here instead, right? Well, it's going to be true because this first one is true, and the second one is false, but the first one is true. Okay. Ah, daggone, I did again. Alright. What did I do? Alright, now, there it is. Wrong one. So sorry. Alright, there we are. Success, of course. Now, what if I were to set them both to false, right? If I made that one 4. So now that one's false and that one's false. What are we going to get? Should get a fail, right? Because on OR, the only time you can get a false on it overall is if both are false. And so we did, we got a fail. Now I'm going to show you that we can swap to where they're both true and it still is true. So if I make 5 here and I make this one 10, so now they're both true, right? And the whole thing's going to be a success. Success right here. Bam, worked again. Awesomeness. So that's our little point in our program right now. But we'll continue with our small child simulator here in the next video as we get a little bit more interesting with it. So this ought to be fun, and it ought to be interesting how we can handle this. So I showed you one way of doing this, but there's actually a really neat, cool way of doing it better than what we did that even executes faster and it's more efficient. So we'll get into that in the next video. But so this is Nate Nestler for Hyperactive Studios, and I hope you had fun. Thank you very much.